Hey guys, this is lesson 3, adding and subtracting rational expressions. Now, we're not going to do the adding and subtracting of rational expressions of unlike denominators. There is going to be one problem, so I do have to show you how to do that, but most of the problems you do are going to have the same type of denominator. So what I mean by that is, let me give you an example. So here's example number 1. We're just going to add or subtract. Then simplify. Now this lesson is going to be a little bit, I hope, on the easier side for you guys, but we'll see how this goes. And then lesson 4 is going to be a little tougher, so that one might take us a little bit more time to go through. But here we're just going to add or subtract and then simplify. So part A, let me give you the first example. It's 2x minus 3 over 4x. Plus 3x plus 10 over 4x. Now, normally whenever you add fractions, you hope that the denominators are the same because that means you don't have to do anything special. You just got to add the numerators together and you're good. If you notice here, our numerators are different, but our denominators are the same. So that's good. If our denominators are the same, then all we have to do is add straight across from the top, right? We're just going to add this way. So I'll take an extra step here and I'll write this out. 2x minus 3 plus 3x plus 10 all divided by 4x. Now let's go ahead and add our like terms. So 2x plus 3x, that's 5x, and negative 3 plus 10, that's a positive 7 divided by 4x. So now all you have to do is ask yourself, is there anything on the numerator and denominator that everything shares that we can cancel out? They don't have anything in common. So we're just going to leave the answer like this. So here's our first solution for the first expression that we had to actually add together. Now, let me give you another one that looks a little bit more difficult, but you're going to see it really isn't that much more difficult. But at first glance, you're going to think that this is going to be a lot harder to do. So we have x over the trinomial x squared plus 3x plus 2. And then we're going to add 2 over the same trinomial. So again, we do have the same denominator, so that means that we don't have to worry about creating a brand new denominator, or it's called the least common denominator. We're not going to try to find that. We're just going to leave it alone, and we're going to add these things together. So again, we're just going to add straight across. So this is over x squared plus 3x plus 2. Now, if you remember the instructions, it said to add or subtract and then simplify. Okay, so the bottom can be simplified. Okay, the top is just an x plus 2, so there we go. But the bottom portion, we can actually use an x method for that. So on top we put a 2, on the bottom of this x we put a 3. Two factors that multiply to 2 that add up to 3 are a positive 1 and a positive 2. So that means that I have x plus 1 times an x plus 2 in the denominator. Now you should notice that we have matching binomials, right? An x plus 2 in the numerator, an x plus 2 in the denominator. So that means I can cancel these out. A 1 remains on top, because whenever you cancel everything from a fraction, you always have to at least leave a 1. And the x plus 1 remains on the bottom, and that is your solution. So there's an addition with a simplification. Now, for this last one of adding and subtracting, let me give you this problem here. Y over 3 minus 2y plus 4y over 2y minus 3. Now you'll notice so far I haven't given you any subtraction problems, but the truth of the matter is C is actually a subtraction problem, but you're going to see how it's going to happen. Okay, because when you look at this, you're going to say, well, wait a minute, these two denominators are not the same. And you said that we're going to be doing same denominators. And that's true. They are not the same, but they are almost the same. Now, you guys learned many years ago that if it was addition, you could just flip the numbers around in the denominator, but we can't do that because it's subtraction. But if we flip a subtraction around, what has to happen is you have to drag out a negative. So let me show you what I'm going to do. I'm going to make the second fraction, okay, this part right here, match the first binomial in the front. Okay, so here's how I'm going to do it. Y over 3 minus 2y, then plus 4y over, now I'm going to write this in a different color here. I'm going to write 3 minus 2y. Now I notice I flipped it, but in doing that, it's actually not correct. The way I correct it is by putting a negative in the front. And then that is a true statement. Okay, whenever you flip a subtraction, you can do it, just make sure you put a negative in front. So now that I've done that, I'm going to continue. I get y over 3 minus 2y minus 4y over 3 minus 2y. Notice all I did was I got that negative in the front of that parenthesis and moved it to the front where the positive is, right? These two, I kind of combined them to become a minus sign. Now, since they have the same denominators, then I'm just going to do a y minus 4y, which is a negative 3y. And on the bottom, I have a 3 minus 2y. Now remember, you can't just cancel out a y. You can't just cancel out a 3. You have to make sure that you cancel out the whole expression. So if you wanted to get rid of a 3 or a 2y on the bottom, you had to have the same expression up on top. So that means that we're done. So let me just highlight this here for you guys, and that would be your answer. All right, now we're going to move into something called the least common multiple. Okay, so the least common multiple. Now you may already know how to do this because this is something you've done, I don't even know, for years. You've probably been doing this since 6th grade in terms of numbers. Okay, so that's what I mean. You may have seen problems where you're like, okay, what's the least common multiple of, let's say, 4 and 7. So the way you used to do it a long time ago, you used to say, okay, well, 4 times 1 is 4, times 2 is 8, times 3 is 12, times 4 is 16. And you used to do this over and over and over again, just kind of going through these numbers, right? And then you used to do the same thing with 7. So you'd say, okay, 7 is 7, and 14, 21, 28, 35, 42, 49, etc. And then when you did this a long time ago, you used to say, oh, well, okay, all I have to do is find the multiple that they have in common. So the multiple that they have in common, the earliest one that they have in common is at 28. That's the number that they share for the first time. Then there could be more that repeat, but that's the number that they share for the first time. So 28 would be considered the LCM. Okay, so we could say that the LCM of 4 and 7 is 28. Okay, now just to show you what I was talking about, repetition. Let's, I don't know if you heard that, but that's my dog Lola. I think you guys have heard about her. But let me just do another one of these little tiny examples just to kind of prove a point. So if I asked you what's the LCM of 2 and 4, we'd write 2, 4, 6, 8, 10, 12, 14, 16, etc. And then let's do 4, 4, 8, 12, 16, 20, 24, etc. You're going to notice that they match at 4, they match at 8, they match at 12, they match at 16, etc. They match many times. But when they say what's the least common one, well, they have a lot of common ones, but the least one, meaning the smallest one, is this one. So that's why we would say that the LCM of 2 and 4 is 4. Okay, so hopefully this kind of just reminds you of what you used to do before in terms of numbers, because what we're going to be doing is numbers and letters. Okay, now finding the least common multiple for letters is actually very simple. I'll write it down. To find the least, let me just write LCM, the least common multiple for variables, use every variable given and find the highest power. Okay, so highest power for every variable. Even if they don't all share the same variable, it doesn't matter. If one of the terms has an x and the other one doesn't, it's okay. You still use the x. Whatever the highest power is on that variable x, you're going to use it. Okay, so this is least common multiple. So here we go. Let's show you this stuff here. So find the least common multiple. So to find the least common multiple of the following, we're going to follow our rules. Okay, do the numbers first and the letters second. So 3n squared and 8n. So let's think about this. What numbers do 3 and 8 both go into, right? What multiple do they share in common? Okay, now they both go into 48 and they both go into a bunch of other numbers. But what's the smallest number that they both go into? So 3 and 8, they both go into 24. Okay, 24 is the smallest number. Now, if you don't know why I say that, let's just kind of do it one more time. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So that's 3. And then 8 is 8, 16, 24, 32, 40, etc. The very first time they have matching numbers is right here. That's why that's the least common multiple. Now, the next part, like I said, is the easy part. Which letters do both of these terms have? So if you look, they have an n, and that one's squared for 3n squared, and they have an n for the 8, right? 8n. So you're going to use the letter n, and then you ask yourself, what's the highest power I see for the n's? Well, this one is a 1, and the other one is is a 2, so I'm going to write 24n squared. So that's my LCM, okay, 24n squared. So let's try doing another one similar to this. So 5x cubed and 7x. Excuse me. So 5 and 7. Okay, what number do they have in common? Now, again, they can have many numbers in common, but what's the smallest one that they have in common? So if you start thinking about it, the first time these numbers ever meet up is going to be at 35. Okay, so that's my numerical least common multiple. Now for the variables, I notice they both have an x, so I'm going to write x, and then the highest power I see is a 3, so there's my answer. Okay, 35x cubed. All right, so let's move on. Let's do 10x to the 4th and 6b squared. Now you'll notice, let me write and here, 6b squared. You're going to notice they don't have the same variables, and that's okay. It doesn't matter. With the LCM, if they don't share the same variables, it's fine. If this was a greatest common factor, then it does matter because they both don't have an x in common. They both don't have a b in common, so we can't factor anything out. But for an LCM, it doesn't matter. So here we go. 10 and 6. When is the first time they meet up where they match up? So let's think 10. 6 doesn't go into 10. 10 becomes a 20. 6 doesn't go into 20. 10 can become a 30, and 6 goes into 30. So then we can write 30 as the first time they meet up. Now, I remember I told you, you're going to write every variable you see. So I see an x and I see a b. Okay, and take that variable to its highest power. So x to the fourth is the highest I see, and b squared is the highest I see. So therefore, the LCM is 30x to the fourth b squared. Okay, now why do we have you guys doing this? Well, because there is going to be one problem where they're going to want you to add or subtract, and only one, of an unlike term. I think it's only one if I remember correctly. So for part D, they might give you a problem that looks like this. Or not they might, I know they are. So this is how you do this. First, you got to find the LCM. Okay, so let's find the LCM between 2x and 3y. So let me do that. The LCM of 2x and 3y. So 2 and 3, the very first time they have numbers that meet up is at 6, okay? Because 2 times 3 is 6, 3 times 2 is 6. That's the first time it happens. Then I'm going to write each variable, x, y, to its highest power, which both of them have highest power of 1 and 1 for both of them. So now what you're going to do is you're going to say, okay, I need to have a 6xy in my denominator. So what I'm going to do is I'm going to write 3 over 2x is the same thing times something, and then plus 4 over 3y times something. Okay, that something that we're looking for is a number that will make my denominator 6xy. So let's look at the first denominator here, this 2x right there. I want that to become a 6xy. So in order for that to become a 6xy, I'm going to multiply by 3y. So I got to do top and bottom by 3y. Now, if I look at my second denominator, 3y, and I want that to become a 6xy, then I'm going to multiply that by a 2x on top and on bottom. Okay, so let's go ahead and work this out. We get 9y over 6xy plus 8x over 6xy. Now notice how my denominators are now the same. Since my denominators are now the same, then I'm just going to add these things together. So remember, you add straight across. 9y plus 8x over 6xy. Okay? And that's going to be my solution. Notice how we needed to find our LCM for something like that. And then that's how we can combine these things together. Now, there's one last thing I got to show you guys, and it's just really quick. Sometime in your homework, they're going to ask you to find the least common denominator. Least common denominator. So all you're going to do, I'm just going to put right here, just multiply the denominators. Okay, so for this lesson, just multiply the denominator. So let me just give you a real quick example of this, and we are done. Okay, so example number 3, we're just going to put find the LCD, the least common denominator, and it's going to look like this: 2 over x plus 1 minus 3 over x minus 1. So they just want the LCD. So remember, to find the LCD, just multiply the denominators. So x plus 1 times x minus 1. Well, if you FOIL this, right? If you FOIL this out, you're going to do those two first. That'd be x squared minus x. And then FOIL that down here. That'd be plus x minus 1. That becomes x squared minus 1 because these right here are going to cancel out. And that is your LCD. Okay, so your least common denominator is x squared minus 1. So hopefully this helps you guys. Again, if you guys have any questions, please let us know. Okay, we're here to help you guys for the rest of the school year. You know, we get bored too. So by giving us stuff to do, you can either visit us at our office hours, or we're going to try to create some office hours maybe during Thursday. Okay. All right. Have a good day, guys.